Hi everyone, happy Friday. Today we're going to look at the graphs of sine functions and the ways that we can transform those graphs by adding things to the initial equation. Please copy everything that's on the board down into your notes. So you should have a paper and something to write with out on your desk. If you don't have those, please pause the video and get them. Look at the graph of a sine function. F of t equals sine of t. So the function where the variable is t, the sine graph. The amplitude is 1 because the graph goes up 1 unit and down 1 unit in the y direction. The period is 2 pi because the graph goes up above the x-axis and then down below the x-axis and ends up where it began over the span of 2 pi in the x, or in this case, t direction. This is a standard sine function without any transformations. So if someone asks you to graph sine, this is what they're looking for. Now let's compare the graph that we just looked at with this graph of g of t of 3 sine t. So the function g with the variable is t of 3 times the sine of t. What's the difference that you see between this graph and the graph on the previous slide? Let's look at the width of the graph first, or the period. The graph goes up above the x-axis and then back down below the x-axis, starting at 0 and ending at 2 pi before it repeats itself, just like on our previous graph. So, in this case, the period is still 2 pi. But let's look at the height of the graph now. It goes up to 3 in the positive y direction and down to -3 in the negative y direction. So our period stays the same at 2 pi. But our amplitude, or the height of the graph, has changed. Our amplitude is now 3 instead of 1 in our previous graph. What do you think caused the change in amplitude in this graph? You see there's that 3 before the sign. So when you have a number multiplying by the sign, that's going to change the amplitude. If the number is greater than 1, the graph is going to get taller, like in this case where the number is 3. If the number is less than 1, like if it's a fraction, then the graph is going to get shorter. Let's compare another set of graphs now that you have those copied down. So we have again f of t equals sine of t. But then we have our other graph, which is h of t equals sine of 2t. This time that extra number is inside the parentheses. What's the difference between the two graphs now? In our last example, the amplitude changed. But let's check our amplitude of our original graph against the amplitude of this graph. Both graphs go up to +1 and down to -1. So it looks like our amplitude stayed 1 in both graphs. And we could tell that because there's no number in front of sine. The new number that was added is inside the parentheses. So next, let's look at the period and see if that has changed at all. Remember, in our original sine graph, we go from 0 to 2 pi, and then the graph starts to repeat itself. In our new graph, where we have sine of 2t, our graph starts to repeat itself at pi. So our new period is pi. So in this case, instead of a bigger number causing the graph to get larger, it actually shrank the period of the graph. So when you have a number inside of the parentheses, you're actually going to divide our normal period of 2 pi by that number. So when we do 2 pi divided by 2, we get pi, which is our new period of this graph. Here's another pair of graphs. We have our original, f of t equals sine t, and then we have j of t equals sine of t minus pi over 3. If you look at the second graph, the one in gray is our original sine curve, and the one in blue is our new sine curve. Check our amplitudes again. As you can see, both graphs are still the same height. Our amplitude hasn't changed from 1. This is because there is no number in front of the sine, like we saw in that previous graph a couple slides ago. But what is different about the new graph? Does it look any wider than the old one? Has the period changed? No, the period is the same, but the graph has shifted over to the right. Because the new number that is being subtracted from t is pi over 3. Pi over 3 is the amount that the graph has shifted. An important thing to notice in this second function is the minus sign. The minus sign is what indicated the direction. When it's the variable minus a number, you're shifting the graph to the right. When it's the variable plus a number, you're going to shift the graph to the left. So minus right, plus left. Okay, one more pair of graphs to compare. Let's take a look at f of t equals sine t, our original graph that we've been looking at all along, and k of t, which equals sine of t plus 3. This time the 3 is outside of those parentheses. So let's look at our amplitude. We go up +1 and down -1 in our original graph. With this graph, we start at 3 and go up to 4 and down to 2, which is still a change of only 1 in each direction, meaning our amplitude is the same. Our amplitude is still 1. Let's look at the period. The graph starts at 0 for our original graph and goes to 2 pi before it starts repeating. And this graph does the same thing. It starts at 0 and goes to 2 pi before it starts repeating. So the period is still 2 pi. So if the amplitude and period haven't changed, what has? If you notice, our other graph starts at the point 0, 0. This graph starts at the point 0, 3. So that plus 3 on the end of the function has caused the graph to start at a higher y value. So the whole graph has shifted up by 3. In this case, when we're talking about the up and down direction, plus means that we're shifting the graph up, and minus is going to indicate a shift down. So let's think about the position of the numbers in the functions we just looked at. If we're adding a number inside of the parentheses of the function, adding or subtracting, that's going to mean a shift to the left or to the right. If we're adding or subtracting a number outside of the parentheses, that's going to indicate a shift up or down. So inside the parentheses is that side-to-side motion. Outside of the parentheses is the up and down motion. Now let's take a look at this graphing calculator screen. Here we have the sine function. This should look pretty familiar because we've been looking at it all lesson. And I want to compare this to the cosine function. So the sine function starts at 0, 0, goes up to pi over 2, comma 1, goes down to 3 pi over 2, comma -1, and then back up to 2 pi comma 0. Cosine is a little different. Cosine starts up at the point 0 comma 1 and then goes down. So it immediately decreases instead of increasing like the sine function. It's going to go down to its lowest point next, which is going to be at pi comma negative 1. Then when it finishes its period of 2 pi, it's going to end back up at a y value of 1. So cosine and sine graphs are very, very similar when it comes to period and amplitude. Cosine just starts about a quarter period over from where sine starts. Now we're going to practice some of these transformations. The sub will give you a worksheet, and I want you to immediately cross off some problems for different types of functions that we haven't talked about yet. So we are only going to look at sine and cosine functions because they're so similar. So you can cross off any functions that are not sine and cosine. So that's going to be problem 3, problem 5, and then on the back of the page, we're going to cross out a few more. So we're going to cross off numbers 7 and 8. And then 10 and 12. So the worksheet doesn't look so intimidating now that we crossed off all those problems. So give these a try. I want you to notice one difference on the front side of the paper. So far we've been talking about the period of the graph in terms of radians. We've been talking about 2 pi. So what is 2 pi equal to in degrees? That's right, 2 pi is equal to 360. So when you're thinking of a normal period of a sine function or a cosine function on these graphs that are in degrees, instead of going from 0 to 2 pi, we're going to go from 0 to 360. So 180 degrees on the graph would be like pi, 360 degrees would be like 2 pi, 540 degrees would be like 3 pi. So hopefully you guys can figure this out. I think you've got it, and we'll go over any questions you have on Monday. So I hope you guys have a great weekend. I'll see you on Monday.